Hello everyone, this is Robert, and I have a little bit of a problem that I need to solve. For my new laser workstation, I have my CO2 laser, my fiber laser, but only one fume extractor. So I need to figure out a way to kind of combine these so that I can use the one fume extractor for both of them. I need it to be easy to use, simple, all that good stuff. So let me show you a couple ideas that I came up with. My first thought was to use a simple Y splitter. One side goes off to the CO2, one side goes off to the fiber, and then the other side goes over to the air purifier. This is really simple, but the only problem is that it's really wasteful in terms of airflow. Since it would be sucking from both lasers at the same time, you're not really concentrating that airflow to the machine that you're actually using. So although it is the easiest, it's the least effective for the solution. But this is exactly why blast gates exist. As you can see, I've got one on each one of these hoses, and this will isolate this hose. Now all the flow goes through there, and if I want to switch it, I can press this one in and open that one. Nice and easy. Well, the only problem is these hoses are going to be behind the machines and going down below in the back of the cabinet, so it's not really going to be accessible. I could make it accessible, but it's a lot of stuff to kind of fit in there. The other issue, which isn't that big, is that you have to control each one of these individually. So right now, everything is blocked off, and to open it, I have to control each one individually, which is a little bit of a pain. You would never really want them both open at the same time. So there's a better solution. So the most simple, straightforward, and reliable solution is going to be to just connect this hose to one, disconnect it, move it to the other, and vice versa. The YouTuber in me always wants to overkill and over-engineer everything, so I thought about some sort of sliding system that would slide between these two, maybe even motorized with some sort of servo that would kind of do that. Unfortunately, I only have the P2 CO2 laser. The P2S actually does have a Bluetooth connection, so I could probably use Home Assistant to read which laser is running and do some magic. But this is going to be a manual process. I'm going to have to go over and turn on the air purifier anyway, so this is just going to be manual. So let me bash at the keyboard a little bit, press print, and show you what I come up with. So here's what I came up with as kind of the first proof of concept prototype. Each one of these tubes will connect directly to a respective laser. These little recesses right here are for magnets, and this whole thing will attach to the rear back side of the cabinets with the magnets, kind of like a little flange. And then on the front hand side, we have two recesses, and these will be for the hose connectors that will just magnet into place. Keep in mind, I actually have to use this thing. So as much as I would love to do some crazy motorized thing, I'm the one that has to plug it into power, maintain it, and it's inevitably gonna not work when I need it to work. I'm using this bamboo PLA support material for the interface, and I really like it. This was my first kind of like real time using it, and I will say it does a great job. I didn't remove it here just for the video, but a sharp chisel will just pop this right off, and you're left with a really, really nice layer underneath of it. It looks basically the same as a top layer would. So because this is printed like that, I needed to have some supports on the underneath side of this geometry. This is black little foam tape. This stuff is super cheap, easy to get. Get on Amazon, link down below. It's 8 millimeters thick and just stuck in there. It has double stick tape or adhesive on the back of it, and you stick it in there, and that'll be a nice gasket for the connector to go into there, held by magnets, nice and simple. There's a lot of changes I want to make on this, so let me make a lot of changes, and I'll be right back. So I managed to shrink this down quite a bit. Just kidding, I just cut it in half for this prototype print. The first big change I made was to add a gasket of that same foam tape. This is the interface that goes against the cabinet. The hard plastic against the painted metal, it would kind of slip around a little bit, but with this gasket, it doesn't slip at all. I decreased it from 4 magnets down to just 3. That is more than enough. We'll talk about this cool spiral in a second. And I also kind of modified a lot of the geometry inside there. I added quite a bit of a draft so that the mating piece fits really nice. It just drops in there. I'm going to do one final tweak. I'm not going to have magnets in both sides. It's just kind of excessive. These will just be screw heads, and that'll be plenty for the magnet. And just kind of change some geometry overall. But the threads, those were the real kicker. They thread perfectly onto this. No one likes hose clamps. So it is much nicer to just have this thread directly on. And that will be on both sides, the laser, and also on the other mating side. This is a really, really nice filament. This is Bambu's PLA carbon fiber. Just really, really pretty stuff. I'm trying to kind of match the theme of the Xtool with the dark charcoal and the green. But yeah, really, really happy with how this all turned out. It took a little bit of tweaking to get this right and get the geometry on these threads right, but I think I'm ready to print the final version. I printed everything out on my Bambu H2D, the non-laser. I'm using the support filament in the left nozzle and the primary filament in the right nozzle. I'm using Bambu's PLA CF for the base as well. This is the lava gray, and it prints really nice. There's a little bit of cleanup that's needed after the print comes out. I did realize that my support filament's probably a little bit too moist. I really should have dried it, and spoiler alert, I'm gonna go back and re-dry and reprint this. But with a little bit of careful pressure and just kind of slightly breaking the supports away, you can usually get most of them off in one go. With the other piece that you saw earlier, I just kind of ripped it off the printer and immediately tried pulling off the support structure, and it left all of the interface material there. But if you're really careful and do this right, you can usually get the interface material to come with it, and then it just takes a little bit of cleanup with a chisel. After all the support interface material was cleaned off, the next step is to add threads to the 8 holes on the surface. Those will accept screws, and then that's what the magnet's actually attached to. But this is where I ran into my first issue. I had the holes sized incorrectly. So as soon as I put the tap in there, I realized that it's basically just kind of rubbing against the side. The hole is too large. It's not actually cutting any threads. I looked at the SolidWorks model and found out that I had sized this for a 1032 through hole, not a 1032 tapped hole. So the sizing was wrong. I thought I could maybe just use a little bit of super glue and glue the fastener in place, but unfortunately the head profile is wrong as well. The screw head is going to sit way too proud. It's going to sit too high up. That's not going to work. I tried using a countersink, but it's way too easy to just blow through those top layers, and then you're just basically into the infill. It looks ugly. The screw's going to sit kind of wonky. There's nothing supporting that middle hole. So this is going to have to be reprinted. But I'm going to go ahead with this assembly to see if I find any other issues. Some of you might be wondering why I didn't use the fancy H2D to just print a TPU gasket directly in the model. And I thought about that, but there's a couple reasons. One, I only have 2 nozzles on this. So one of them is used for support, the other is used for the primary filament. I'd have to do some sort of switching, I think, with the support material, and then you potentially run into some issues. Also, the prime tower gets a little bit weird with the 3 different materials. TPU also does not stick to PLA carbon fiber, so I would have had to switch over to PETG, and I don't have a support material for the PETG. I only have it for PLA, so that was another issue. But mostly it's just not the right material for this gasket. The foam tape works really, really well, is cheap, it's easy to put on, and it also doesn't take a lot longer. TPU takes forever to print. It would have slowed this print down by at least an hour or 2. So I don't know. I like the idea of using TPU in these multi-material prints, but I've never really come across a situation where the foam tape wasn't just the easier, better, cheaper option. So I'm going to stick with the foam tape for right now. So I have this all together, and I'm not super thrilled with how it functions. This fits, the geometry's fine, but the magnet force really isn't that much. I'm worried that if it's sitting like that and there's a hose attached to it, it's going to be really easy to just kind of accidentally knock it off. Granted, when this thing is running, it's going to suction into itself a little bit, so that's going to help. I also really don't like the exposed magnets as much as I thought I would. I thought it'd kind of look cool, but I really don't like it. They also sit flush, but because of the chamfer on there, it looks like they're sitting up from the surface a little bit. And I think I can fix a lot of my issues with this as well. The foam gasket sits a little bit too high. I'm going to recess that down. I thought the magnet force would kind of squish it. It really doesn't. So I'm going to set that down a little bit, and I think I'm just going to get rid of the screws completely and have these larger magnets just pressed in from the back like that. You won't see them in the same way as these. You won't see them when they're pressed in from the back. That'll leave a nice flush surface here. And then for the face of this, I can use these countersunk magnets just stuck in the face, so you won't see anything from that side. So let me go make some changes and get this all reprinted. I've been using the F1 Ultra a lot to laser mark 3D printed parts, and I think this is a good application for it because I'm not going to know which port is connected, which one goes to the CO2, which one goes to the fiber laser. So I want to do some sort of basic labeling on the part so I know which one's which. I printed out a test sample and then engraved it. This is a file that comes from Batch Resource Labs. I think that's their name, linked down below. And it gives you an idea of the different settings. And this is the exact filament that I'm using for the body. And instead of just going with a standard text label like, Xtool P2 or F1 Ultra, I decided to do scale models of the actual laser. So these are actually fully dimensionally accurate scale models. And I don't like these specifically, but I kind of have a better idea. So let me kind of mock that up. Let's wait for that print to finish and I'll show you what I got. Although this second print was a lot better after drying both the support and the PLA carbon fiber filament, it's still not perfect. There's still a little bit of that support interface material kind of embedded in that layer that you just really can't get out. So there's still some white specks left in there. It did remove a lot cleaner. It was a lot easier to just kind of pull this off. It broke away, and I really didn't have to chisel that much away. But there's still some improvements to be made. The surface finish is much better than you would get by using traditional organic or standard support. So the interface is definitely doing something, but it still kind of gets embedded a little bit in that top layer. So I'm going to mess with this just, in future projects, and I'll let you know if I find out the perfect settings for this. It's always really satisfying when you have a part like this that interfaces with other things or has pieces screwed into it, that you get all the tolerances and dimensions just right. And these magnets fit in perfect, the screw sizes are perfect, everything screws in nice and clean, no issues. So all those little tweaks and changes I made are paying off. So I'm getting the magnets installed, I'm getting the foam tape installed, and we're going to get this thing finished so we can send it over to the laser and add some nice engraving on it, and then we'll be done. So now I need to get this set up on the laser. As you can see, I've got these 4 screws installed in the bed, and this will give us a reference for the part. So I'm going to use a couple handy 1, 2, 3 blocks resting against those screws, just kind of using these as posts. That'll give us a nice surface to then rest the part against because it's, kind of weird geometry. So this will sit in like that, and I know that this is now squared to the laser bed. You might be able to see there's a blue dot and a red dot right there. These are used for the focus. We're way too low, so I can hit the up button, and when these two converge, then we're in focus. I could also use the Vision camera system to focus it, but I kind of like doing it this way a little bit better. So we'll just wait till those are lined up. Cool. So now the laser head is focused. I'm going to go over to the computer and we'll draw the outline on this so we can get everything lined up this way. And then It'll just be a matter of hitting go and marking it. So I have this job set up with two different layers. One is the outline of these two features, and the other is the icons that I'm going to engrave. These are disabled right now, and I have these enabled. So if I hit the framing button, it will show me the outline, and I can just simply nudge this into place. And once that's lined up, I know that my other feature is going to be lined up. So I can disable this layer, enable this layer, and then we can mark the icons. So everything's set up, and I have the lid lifted so that you can see this better, and I'm not really worried about fume extraction. You'll see why in a second. Don't blink. And that's it. Let's go take a closer look at it. So here are the finished parts. I've got the F1 Ultra up top and the P2 down below. The engraving, I think, looks really neat. I like icons versus text. It's just kind of more intuitive, and it's a lot cleaner. And you can see just a little white spots all along there. Something I need to figure out. This isn't perfect, but it's pretty good. And on the back side, you can see the magnets and the foam gasket. And everything works really, really well. It's got a nice strong hold on there. That's not going to come loose. It's really kind of hard to get off of there. Pulls right out. So yeah, I think I'm happy with that. All that's left to do is just get this thing installed. I'm using the hoses that came with the machines from Xtool to go into the manifold, but coming out of the manifold into the air filter, I'm using some aftermarket 4-inch dust collector hose. And the reason I'm doing that is because the ones that came with Xtool are very rigid. It's kind of like this rigid black plastic. They screw really nicely into the back of the manifold, but they're just not very flexible. The clear stuff is very flexible, so it'll be a lot easier to switch between the two machines. And because it's clear, I'll be able to kind of look at it and see if there's dust or smoke, stuff like that coming through it. In the end, everything worked out. The manifold fits really tightly on the back of that cabinet. Looks really nice. The only way you can really slide it is to kind of lift up one side, break the force of the magnets, move it, and then snap it back in place. But with the magnets and that foam gasket, it holds really tightly on there. All of the hoses are stuffed down behind the cabinet so you can't see them. I really was not wanting to have a lot of visible dust collection here, and it's all kind of tucked away, which is really nice. And moving between the two different lasers is really easy and intuitive. I would have liked this to be automatic, but the manual process is going to be perfectly fine. It functions exactly how it should. The only thing I need to figure out for next time is how to get that interface on the support material to be just a little bit better. From a few feet away, you can't really see it, but I think it can be improved. So I'm going to work on that, but overall this whole project has been a win. Thanks for watching. Check out the links down below, and I will see you in the next video. Bye.